The method we describe here to factor ax squared plus bx plus c is sometimes called the AC method, or the master product method, or the key number method. Here's a summary. Find two numbers s and t whose sum is b and whose product is a times c. So s plus t is b and s times c is ac. Split the term bx into two terms. Bx is sx plus tx. Factor the four-term polynomial ax squared plus sx plus tx plus c by grouping. Some remarks. This method does not always work, since there exist trinomials that do not have a nice factorization. Always check that s plus t is b and s times t is ac. Finally, the method described in the previous section is a special case of the AC method, namely where a is equal to 1. Let's illustrate this with some examples on page 39. Question 1. Factor 6x squared plus 7x minus 5. We are looking for two numbers whose sum is 7 and whose product is 6 times negative 5, which is negative 30. We see that 10 and negative 3 work. 10 plus negative 3 is 7, and 10 times negative 3 is negative 30. So we factor by grouping. 6x squared plus 7x minus 5. The first thing we do, since the numbers we had were 10 and negative 3, is rewriting 7x as 10x minus 3x. Now we continue the technique of factoring by grouping. So we split into two groups. Since the third term starts with a negative sign, we factor out a negative sign in the second group. Next, we factor out the greatest common factor of each group. For the first group, we have 6x squared and 10x. The greatest common factor is 2x. We factor out 2x, and we are left with 3x plus 5. For the second group, we have 3x and 5. The greatest common factor is 1, so we cannot factor out any terms. Finally, we factor out the common binomial 3x plus 5 and are left with 2x minus 1. Hence, we have the factorization. 6x squared plus 7x minus 5 is 3x plus 5 times 2x minus 1. Question 2. Factor 21x squared minus x minus 2. We are looking for two numbers whose sum is negative 1 and whose product is 21 times negative 2, which is negative 42. We see that negative 7 and 6 work. Negative 7 plus 6 is negative 1, and negative 7 times 6 is negative 42. So we factor by grouping. 21x squared minus x minus 2. The first thing we do, since our numbers were negative 7 and 6, is rewriting negative x as negative 7x plus 6x. Now we continue by factoring by grouping. So we split into two groups. Next, we factor out the greatest common factor out of each group. For the first group, we have 21x squared and 7x. The greatest common factor is 7x. When we factor out 7x, we are left with 3x minus 1. For the second group, we have 6x minus 2, in which the greatest common factor is 2. We factor out 2 and are left with 3x minus 1. Next, we factor out the common binomial 3x minus 1 and are left with 7x plus 2. So we have the factorization. 21x squared minus x minus 2 is 3x minus 1 times 7x plus 2. Question 3. Factor 27x squared plus 18xy plus 3y squared. First, we factor out the greatest common factor of all three terms. We have 27x squared, 18xy, and 3y squared, and the greatest common factor is 3. So now we factor 9x squared plus 6xy plus y squared using our method. We are looking for two numbers whose sum is 6y and whose product is 9y squared. We see that 3y and 3y work. 3y plus 3y is 6y, and 3y times 3y is 9y squared. So we factor by grouping. We split the term 6xy into 3xy plus 3xy, since our numbers are 3y and 3y. Next, we split into two groups. Now we factor out the greatest common factor out of each group. The first group contains 9x squared and 3xy. The greatest common factor is 3x. When we factor out 3x, we are left with 3x plus y. For the second group, we have 3xy and y squared. The greatest common factor is y. When we factor out y, we are left with 3x plus y. Now we factor out the common binomial 3x plus y and are left with 3x plus y. So we can simplify this a little bit more by rewriting as 3 times 3x plus y squared. So we have the factorization 27x squared plus 18xy plus 3y squared is 3 times 3x plus y squared.